All righty. Hello, everyone. Welcome. Thank you so much for joining us today. We're glad to have you. While we let everybody trickle in, I will just go over a few housekeeping items. My name's Kayla. I'm here representing the Acelab team, and we have Mindy here from TRA Snow and Sun. She'll be guiding us through the presentation, but before I pass it over to her, I do want to quickly show everyone where you can learn a little bit more about TRA Snow and Sun on Acelab. So in just a minute, you should be able to see my screen. Um, all right, so anytime you're doing any research on Acelab, you can use the search bar at the very top of the screen to search for any specific manufacturer, any specific product, anything like that. In this case, on TRA Snow and Sons page, you've got some really great information. We've got Mindy's contact right here for you to reference. We've got all of their products here for you to explore as well. So feel free to click into any of these product pages to learn a little bit more about what they have. Got some really great information in each of these pages. You can also save it to your firm library for future reference. So definitely check out this page when you have a moment. There's also some case studies, but like I said, a lot of great information. I'll drop the link to this page in the chat for all of you to reference. A couple other things to make note of. This is an AIA-approved presentation, so we already collected your AIA numbers upon registration, so you're most likely already set there. Just in case you're worried that we didn't get your number, I will also drop a form in the chat so you can fill that out to make sure that we have your correct number and that we make sure you get credit for today. We will also be doing Q&A towards the end, so if you have any questions throughout the presentation, at any point you can click the Q&A button at the bottom of your screen. Feel free to drop any questions in there, and then we'll get to as many as we can at the end. And also something to make note of is that we will be doing a poll during the webinar. So you'll see a poll pop up closer towards the end of the webinar. That poll is optional. So if you're not interested in getting any kind of follow-up information after today, you can just click the X, it'll go away. However, if you are interested in getting connected with Mindy and her team after today, fill out that poll and we will connect you via email after the webinar. So you'll see an email a couple days after the webinar come through. It's from a no reply Acelab email address. However, you can reply to that to respond directly to Mindy. Or you can log into your Acelab account and respond to any conversations there as well. So yeah, definitely encourage you to fill out that poll if you're interested in getting more information. I want to make note that when you fill out that poll, if you are looking for samples, it's important here that you share any specific information regarding maybe which product you're interested in getting in samples, or if you have a specific project and aren't sure what sample would be good to have for that, you can just kind of share any extra information in the very last question of the poll where asked for additional information. Anything additional there would be really helpful when we're getting those samples to you. Yeah, that's the last thing I wanted to make note of. So with that being said, I'll go ahead and pass it back to Mindy.
Perfect. Thank you so much, Kayla. I am Mindy Dahlquist. I am the Business Development Manager at TRA Snow and Sun. I apologize that my video is not coming across today for some reason, but we can just pretend like I still look like this picture right here. I've worked for TRA Snow and Sun for over 4 years now, so they have been wonderful to me. This is a AIA accredited course. It's also has a few other accreditations, so if you need any other type of certificate, just let me know and I can see if that's something that I can provide for you. This information has been researched, assembled, and produced by TRA Snow and Sun. We're a pretty small company, but we handle things very face-on. So if you have any questions or concerns about the content of this course, please just let me know. I'm more than happy to involve our in-house engineers and any other person that may need to provide some additional information. Basically, what we're going to discuss today is kind of review the problems, safety issues, and solutions that are currently associated with snow and ice moving on the roof. We will particularly focus on those heavy snow accumulation areas, but we also will kind of jump back and forth into those lower snow loads as well. This is something that I take very much to heart. I lived in Utah for 5 years and just recently moved back to Ohio, where I'm from. Our snow loads in Ohio are pretty low, so like 26 pounds per square foot is my personal snow load for my area here. And I actually had my gutters taken off last year. It's a metal roof. It's about a 612 pitch or slope, whatever you want to call that, of the roof. And so it's definitely something that can take place in any of those lower snow load areas as well. But most of my presentation will focus more on the higher snow loads. So something above a 50-pound per square foot snow load and up into those mountain regions as well. This course is designed to help professionals such as yourself bridge that gap that's created by the absence of codes and standards in modern day to be able to relate to anything that has to do with snow retention. So we'll go over all kinds of things throughout this presentation, and I will not stop talking the whole entire time. So hopefully we will keep you entertained. I don't believe that the sound will share on this video. I tried to make that happen through Zoom and it was not allowing it. So I'm just going to turn my volume down a little bit here. You'll still get the concept of the snow falling without any sound.
Sheathing type and thickness and attachment type will help you to create architect.
So with that, you can see we are mostly going to focus on those heavy snow load areas. So this is going to be the dramatic side of things. This is in Lake Tahoe, California. So some of the snow loads in these regions can go upwards of 450 pounds per square foot. So massive amounts of snow. When you're building anywhere with higher elevation, you're most likely taking those snow loads into consideration and understanding that you do have to build differently than you do in the valleys. So we're not looking at the light and fluffy snow. This isn't go out and make a snow angel in this snow type of conditions. We're really focusing on those heavy snow accumulation areas. The reason for that is the snow is going to act differently. So the snow that accumulates on the roof glaciates. And what happens with that is it becomes one giant mass of snow and ice. So in those situations when that snow does decide to slide and it's given those perfect circumstances to move, it moves as one giant mass. Oftentimes it's thought that snow retention is meant to be this little blade up there that cuts this snow into perfect little chunks and lets it fall off. That is not the goal of snow retention. Snow retention is made to hold that snow back from sliding off and doing damage, such as we're seeing in this picture, where this dormer has actually been removed from the front of this house. I always like to take note here and say most of us work pretty long hours, and I can't quite imagine the perfect day where I would want to pull up from my job or from the grocery store and pull up to my house and see this out front. So I think those are the moments where you see that and you kind of just drive away and figure out how to handle it before coming back. So the snow gets heavy and hard. It does not stay light and fluffy. I want to say I am very sarcastic and I know you can't see my face, so that makes it difficult. So if at any point you think that I may be joking, I probably am. Facial expressions are huge to me. So there are no codes or standards that currently do exist for the engineering, manufacturing, or installation of snow retention in the US or Canada. So that can be quite messy. With the building codes being silent, this does result in at least the following that we as manufacturers are aware of. So at this time, snow retention manufacturing companies are able to make their systems however they want and out of whatever materials they want. So I like to always pick up something random that's around me, and I have a little bottle of fingernail polish on my desk. If I wanted to take this bottle of fingernail polish and sell it to you and say, this is a snow retention device, all you need to do is super glue this down to your roof and it'll hold that snow back. At this time, there is no standard or code to reference that says this little chunk of glass is not going to be able to hold that snow back. It's not going to be able to safely retain it. So with that, manufacturers are basically able to say whatever they want about snow retention at this time. Because of that, without having any standard to reference, municipalities have a difficult time codifying snow retention. There's just nothing for them to reference. In areas such as Truckee, California, Lake Tahoe, California, they know that snow retention is necessary, but how much snow retention is necessary? Do they just need 6 brackets above a doorway? Is it one fence? Is it one fence that goes the entire distance of the roof? There's just nothing for them to reference to require it. Since it's not required by code, owners oftentimes don't want to pay for it, which does result in a lot of retrofit situations where you're coming back to the job 2 years later and trying to figure out how you can install snow retention without messing with the integrity of the current roof system. That's something that we're seeing so often right now, just because the owners don't want to pay for it at the time of roof installation, but then have some type of problem related to the snow. And architects also have a difficult time knowing exactly how to specify that snow retention as well. So what are some of the common hazards and challenges that are caused when the snow does move on the roof? Personal injury and death will be the most serious situation that could possibly occur when you're talking about snow moving on the roof. And then you also move into things like damage from sliding snow and ice, premature aging. I once had an architect ask me if that was for the homeowner or for the roofing product, and so I will never forget that. But if you've ever had to replace your roofing material on your roof, you understand it most definitely could give you a couple extra gray hairs. So we're technically talking about the roofing material, but I think all of those things give us a little extra aging as well. So we'll include that, I suppose. And then limited and restricted access and views and ground snow removal. So I normally have 3 videos here to play. Since I'm unable to share the sound, it's pointless to watch these videos, but they are something that I want to take a moment and just discuss. So these are 3 different videos from news articles or news videos that we've kind of captured and put into this presentation. They're not super recent, but there are recent deaths from snow and ice sliding off of the roof. These are all 3 videos are in 3 different states in 3 different years. And since then, there have been many more deaths from snow and ice sliding off of the roof. Oftentimes, we hear of them when they're in commercial properties, but they happen in residential situations as well. Just last year, the same week, a 5-year-old girl in Durango, Colorado, was hit by snow and ice at Purgatory Ski Resort. And unfortunately, she did pass away. And then that same exact week, there was a 50-year-old man in Utah, in Brighton, who was shoveling snow away from his cabin, and the snow slid off of the roof surface, and he unfortunately passed away as well. These are things that happen over and over again, and each time when the news video comes out, it's always called a freak accident. But if it's something that's happening year after year in all of these different states, at that point, it's no longer a freak accident. This is something that's reoccurring, and we believe that it's definitely preventable in those situations. So we want to really focus on the fact that this is very, very much safety focused, but at the same time, there are other things that come into play. So I'll get much less serious, and we will talk about like the damages to the roofs and other surfaces that it can most definitely impact as well. So this dormer over here has received a little bit of damage from the snow and ice sliding into it. Other design factors, such as a double valley, can most definitely impact the way that the snow moves off of the roof as well. So then you're taking this amount of weight that's sitting on your roof and you're funneling it into a smaller area, such as what we're seeing here in this double valley. And you're just taking those forces in that weight and pushing it into the side of something. I apologize for my dogs. I knew this was going to happen. I have a massive load of wood coming to my house today, and I knew no matter how well we timed it, that it would come right now. So I apologize for that. We're building a little tiny home for my elderly father so that he can be close to us. So it's just part of life, and it is occurring all at once. So as we move on to these other situations where we talk about penetrations and those types of things, we have to understand that these are all going to act differently on each different roof surface. But no matter the type of material that you have on the roof, even these metal conduit that's utilized for electrical wiring penetrations can give way to the sliding snow and ice. We're pretty much aware of this because we do sometimes install crickets behind chimneys, and also penetrations such as these. It's very, very important to make sure that you are considering anything that's sticking up on the roof when you are building or designing in snow regions. Upper roofs that shed to lower roofs are the same thing. You're taking that amount of weight and just adding a lot of motion and a lot of force that's coming down and can just crush these roof surfaces quite easily. When the snow freezes to the roof surface and then moves, it most definitely can damage that roof by taking part of the roofing product with it. And this image here is just going to show the sliding metal panel where the snow slid off of that panel and actually pulled the panel down with it. I think it's important to notice here that the snow actually did not bend this panel whatsoever. So it means that it really slid off of there very quickly for that snow to be able to come off of the roof surface and not bend that panel as well. Here is where my sarcasm will come into play. So another roofing challenges that are associated with snow and ice moving on the roof is going to be other parts of the structure. So it may not be the roof, it may not be solar panels on your roof or your chimney. It could also be other things surrounding your home or surrounding your neighbor's home as well. So I always like to joke when I look at this picture, the neighbor has snow retention, and these cabins look very, very similar. They're side by side. The neighbor also still has that deck enclosure. So luckily these people will be able to go out and just shovel that snow right off of the side of their deck. But for functionality for long run, it most definitely will need to be updated and remodeled. And it's going to take some work to get that back to how it was. Gas meters are something that have been changed within codes and standards to be taken into consideration for snowy regions. But anytime you're dealing with a remodel of a home or anything like that, definitely take those into consideration. It's something that also continues to happen over and over again, unfortunately, with the snow sliding off the roof into the gas meter. And then oftentimes there's a period of time between the time that that snowfall happens and an explosion happens, but I know of multiple cases just over the past couple years where this has occurred. So always keep note of those and the location of the gas meters. Structural damage can also come into play with other parts of the building that do not include the roof whatsoever. This is something that we call creep and curl, so it's not a scientific term, but what is happening here in this photo that we're seeing is the ridge of your home or your building. So the uppermost point of the roof, the very top, is going to be where you have the majority of your heat loss. This is kind of common sense. Heat rises, we all know those things, so it's going to go to the uppermost part of the roof. But as that surface of the roof heats up at the very top, you're going to have that snow that begins to melt and sloughs down towards the edge. Well, as that snow begins to slough down towards the edge, the eave of our roof, so the edges of the roof, are going to be much, much colder. There's a lot more airflow that's happening over and above them, or under and above them. And so it is going to refreeze that snow oftentimes. As you have that snow refreeze, gravity pulls it down, and it can oftentimes just break those windows right out. So this happens pretty often in roofs that do not have as steep of a slope on them. Any property adjacent to your roof definitely can be damaged from sliding snow and ice. These are just some different incidents. One is in New York. I believe the other one is in Montana. The guy in New York was headed towards his vehicle, that Equinox there on the left, when the ice came off of a multi-story building. Where the vehicle's on the right, this one's a little dated, but I love this photo because it's just so interesting how often we see PVC pipe on a roof being utilized as snow retention. So trying to hold back thousands of pounds of snow by utilizing this very flimsy PVC pipe. So this photo here just shows how much that snow wants to stay together once it has already fallen and accumulated and became that one giant mass. This is why snow retention devices are not made to slice that snow up, because it would not matter if we put cute little chainsaws up on the roof. This snow is going to stay in one giant mass until it slides off or is separated in some other way, shape, or form. Premature roof aging. So this is most definitely going to occur on your roof surface. It's something that we're we understand pretty well because it's been happening for centuries. Any type of roof surface that you can have, there's just a lot of freeze thaw cycles that are happening on the roof. That snow is sitting there all year round, whether you want it there or not. And that's something with snow retention that we discuss often, is that the snow is going to sit on your roof until it slides off at any given point. And so snow retention is allowing that snow to stay there and melt off in its place so it can safely melt off and not come down and take the roofing product with it or wear off your protective coating, those types of things that we're seeing in these photos here. The reason for it wearing on that protective coating is the snow is going to be very icy. The water concentration is going to change throughout that snowpack, and it will continuously move on the roof surface ever so slightly. So as things shift, it will most definitely move and go through those freeze thaw cycles over and over again prior to it sliding. Entrances to your buildings and homes can be blocked from snow that slides on the roof. This is something that needs to be understood. It is not going to be light and fluffy snow that you're out there with a plastic snow shovel trying to get the snow out from in front of this cabin. It's going to be ice. It's going to be hard as concrete. It's much warmer temperatures outside. So even though we think, oh, but it's warm outside, that snow will melt, oftentimes it's a block of ice and it is going to take so long for that to melt. Building with that snow shed in mind, such as this cabin here, we have to understand where that snow can go and how far it can go. So there's a garage on the left side of this photo and a beautiful walkway that gets you from that lower garage up to the front entrance that is to the right behind that pine tree. And that whole entire walkway and entranceway is blocked completely by the snow every time the snow slides off of this roof. So the whole entire winter, once that snow slides, it will just continue to slide down that roof surface, come into contact with the rest of the snow pile, and sit there until probably August, depending on where this is. And when we're considering that, we need to understand that any area of that property that is now covered by snow will be not able to be utilized for that time period. Other types of limited restricted access or view could be things such as this. So this homeowner knew they had a problem with that creep and curl that we discussed, where it's breaking out their windows. They've also had issues with penetrations, which is why you see these massive crickets installed behind every penetration on their roof surface. So they decided to do a do-it-yourself type of solution. Let's just cover these windows. If they're covered, the windows can't be broken. Unfortunately, now they have a broken window, two broken window coverings, and they also just have no visible view to the outside world. So not so pretty to live in a very beautiful area if you're not able to see outside. Something else when it comes to removing that ground snow. So if we allow that snow to shed off of the roof, we have to understand oftentimes it does need to be removed. This can be costly. So prior to what I'm doing now, I did some heavy snow removal in Utah, and one piece of equipment per hour cost a customer $350. So if you need multiple people out there and multiple pieces of equipment to remove the snow that's sliding off of the roof, you will definitely want to budget for large amounts of money to make sure that that's being removed. And that's not including any kind of material cost. So any kind of salt or ice melt, this is just strictly for the piece of equipment to be moving on the property. It's very time consuming. It's a very labor intensive, and it's something that if you can avoid it, mostly on like a residential property, it's important. And then when you're talking a commercial property, your customers or clients need to be well aware of that cost up front, or otherwise that first year is really going to scare them. So what are some of the everyday solutions? The sign approach, the caution tape approach, or manual rooftop snow removal? You see these signs all over the place when you're in ski resort areas. They'll say danger, falling ice and snow from the roof. This one says walk well or park clear. It matches the color of the siding. If you end up in any kind of lawsuit situation, they are most likely going to say, you know, you knew you had a problem and you put a Band-Aid on it. You basically chose to do nothing about it besides putting a sign up and pushing that liability back to the customer. And that really doesn't work in that situation. It doesn't remove the liability, it doesn't protect anyone, and it doesn't help anything in the long run. Most likely when snow falls and blows up against this wall, this sign will be covered and will become obsolete completely. Oftentimes these signs are put in very interesting places. So nothing says we care about our customers as much as having handicap spaces and accessibility to our customers, except for when the snow slides right in those same areas. So taking caution and making sure that those accessible properties are actually going to be accessible and safe to the clients and customers. The caution tape approach, as you can see in this photo, there's just a lot of flaws to this one. You're just blocking off otherwise usable areas of the property and hoping that the snow does not slide down on top of it, or somebody's kids are out there using it as a jump rope, or there's just so many possibilities and reasons that this one could possibly not work. Manual rooftop snow removal. This is one of those situations that if you have any form of social media, you have seen all of the fail videos of how this one can possibly go wrong. And there are many hours of videos out there that can be seen to watch how that can end poorly. So some do choose to shovel the roof off every single year. OSHA actually puts out specific warnings as soon as snowfall starts, warning about rooftop snow removal, how dangerous it can be, how there are deaths every single year related to it. In Utah last year, I believe it was, they were announcing that they were utilizing cherry pickers off of the side of the roofs so that when the roofers were sliding off the roof from the ice and snow on the roof, that they were able to just be caught by the cherry pickers. So obviously very, very dangerous, just not the safest situation for anyone to be in. And then you also need to understand many of these guys are up on the roof with pickaxes to get through ice. They have metal shovels, oftentimes spikes on their boots. It's not the best environment to have on a brand new roof by any means. So you're trying to get through layers of snow and ice, but hoping that you don't break through the layers of the roof surface. This is just very, very dangerous, very time consuming. And to show on the right there just how much manpower goes into this to make this function properly and to get through that much snow. So let's take a look at a few design practices in the US and Canada as potential solutions. As a general rule in the US and Canada, we typically design with steep sloping roofs in the mountainous regions and lower slopes in the lowlands. The steeper slopes do allow that snow to slide off much more easily, but we're not really effectively addressing any of the disadvantages and dangers that we just discussed. Europe's design strategy, and I'm not saying that this is correct in every situation, but it's interesting to look at these things, that it's the exact opposite of what we do in the US and Canada. They do choose to use a low slope roof in mountainous regions to prevent damage to the roof. They actually choose to retain the snow on the roof as an insulating blanket. This promotes energy efficiency, helps for safe entrances and exits to the building, and then also just limits your liability, saves some money, those types of things. It does also allow for more architectural freedom, and then also allows for the snow to be up there as an insulator as well. Dormers are something that, whether it was ever intentional or not, when they were first being installed, they work pretty well to hold the snow in place or divert it once it's moving. So they can help protect those areas such as walkways and entranceways to the people that are down below from the snow and ice. But they come with their own list of disadvantages. They can structurally be very effective at diverting that snow or shielding those areas below, but the roofing product is just not made to take that kind of weight and forces of the moving snow. So we don't want to damage our roofs to this type of level just by allowing them to safely keep that walkway protected. Another problem with dormers is there's so many areas on a dormer that are going to alternate regularly between sun and shade. So then you're increasing your freeze-thaw cycles and just adding for the potential of ice damming and all of those other things that can create a large amount of yearly maintenance. So what type of roofing product could help us out here? Maybe a slippery roof, non-slippery roof. Are there any roof types that can be protected from the snow and ice moving on them? So snow and ice are going to move very easily on your slippery roofs, such as metal roofs, composite and synthetic roofs, eco roofs, single ply roofs, and I would probably even include like concrete tile into a slippery roof surface. This is just a quick case study. I don't want to spend a lot of time on this, but in Dallas, Texas, it was game day. There was a little bit of snow that fell. It looks like a lot of snow for Texas, but it was just a little bit of snow. And as that snow slid off of this dome, it did hit 6 people who were entering the Dallas, Texas stadium. So those 6 people filed a lawsuit. And as you can imagine, if you are in a legal situation with the Dallas Cowboys, you're probably going after a little bit of money. They most definitely won that lawsuit and received large sums of money each. So due to this situation, the same management company that managed the Dallas Stadium also manages the Mercedes-Benz Stadium in Atlanta, Georgia, that now has one of the biggest snow retention systems you could ever imagine on it. So it's just interesting to see. This was a conversation that they had had with a consultant prior to installing this roof in Dallas. And they decided against snow retention because Dallas just doesn't receive that much snow. But due to those situations, not only did they have to install snow retention, but the day of this storm, they were up on that roof with firefighters were up there with fire hoses spraying off the ice in the gutters. And due to that, the TPO of the roof was actually sprayed off as well. So they had to do a full re-roof on this and then install snow retention while also closing out a massive lawsuit. So if you're designing in snowy regions, you most definitely need to be considering the snow. If you're designing outside of snowy regions, you need to be considering the type of roof that you're dealing with and if snow or ice or hail or any of that still could be an issue coming off of that roof, such as a dome. So other roofing products are not as slippery, such as tile and slate, wood shingles and shakes, asphalt shingles, and rock-coated metal shingles. Since they're not slippery, oftentimes it's thought that snow and ice will not move on them. So this is concrete roof tile. This is actually why TRA became a business. So TRA stands for Tile Roof Accessories. So that started because of this picture right here. And tile was just getting mashed horrifically within the sorry about that, within the mountainous regions. And so it was something that was researched throughout Europe and all other types of places to determine what and how they handled snow in mountain regions there. Wood roofs are not as slippery as slate and tile, but snow can most definitely still move on those types of roofs. We've seen many broken deck railings, penetrations, solar, all different types of things be damaged on those types of roof surfaces. And asphalt shingles, these are the winners right here. This is the type of roofing material that most designers and contractors will not install any type of snow retention on until they see the problems that can happen for themselves. So snow can move on asphalt shingles, but it's going to usually move at a different time frame. So any of the other roofing materials, that snow can really move at any given point. Where with asphalt shingles, they do have a little bit more friction on them. So usually when the snow is going to move on them is going to be the springtime. So the area that we're in right now, or a little prior to now, where you still have some snow sitting on your roof, but the temperature swings are very drastic. So you can be much, much warmer during the day while the sun is out. And then soon as that sun goes away, everything begins refreezing. The temperatures drop at night. That water that was just running underneath the snowpack can now freeze, creating just a perfect layer of ice between the snow and the roof, just allowing it to toboggan straight off of that roof. So basically, snow and ice can move on all different types of roof surfaces. Modern day snow retention systems, this isn't a concept that we created. As I mentioned, there was a lot of travel to Europe and a lot of dealings with other people to determine exactly what the United States needed as snow guidance or snow control on the roof. And it was oftentimes utilized centuries ago on castle buildings and outbuildings of castles, but it was actually something that was done with boulders or logs. So I always like to joke that I don't want to be hit in the head with a boulder any more than a pile of snow, but you used what you had at the time, and this was something that was utilized for those purposes. Common types of snow retention devices modern day are going to be snow brackets and snow fences. Brackets will lie directly on that roof surface. They will cover the entirety of the roof and they mount to the sheathings, battens, or the roofing product. Where snow fences, they'll act much differently. They actually generally clamp to the roof's seam if it's a standing seam metal panel, or they mount directly to the deck by attaching to the rafters, trusses, purlins, or other types of roof structure. Brackets themselves are designed the height that they are for a specific reason. They need to penetrate about 3 inches deep into that blanket of snow on the roof. The snow then freezes to the brackets, resulting in one large glacial snow and ice mass that's just held into place by those brackets. This is why partial installation of brackets needs to be avoided, because brackets are designed to stop snow from moving. They are not designed to stop moving snow. So no matter how strong a snow bracket is, it can only be as strong as what it is fastened in with and what that roofing material, that sheathing, all of that is, because it's not going into structure. So these are oftentimes placed on the entirety of the roof because they need to act as one insulating blanket that's holding that snow together as one mass, where the fences are going to act a little bit differently. Both systems will allow for proper drainage underneath the brackets and fences and can be installed on almost all different types of roofing material. But the snow brackets, that snow is going to slough down that roof surface and then come into contact with the fences. We still want that snow to freeze to the fence, but they're going to protect more from that roof avalanching, where the brackets are made to just keep that snow in place and never let it get to that point. So brackets and fences can be utilized together. I usually make those recommendations when you're over 120-pound snow load, or if you have a higher slope on your roof. If one fence isn't enough, multiple rows of fencing can be utilized. The snow just stays on the roof and eventually melts off in place. So the perfect example of does snow retention work is that bottom right photo. That's about 6 feet of snow on a 2-bar system being held in place year after year with so much snow. So deck mount fences, as I mentioned, those go into structure. This is just a basic example of that. These brackets and fences can be made on for almost all different types of roofs and from various materials. So I can't speak for competition, but I know that steel, copper, and aluminum is going to be your most common snow brackets that are out there, and they can be powder coated to match most roof colors as well. There are a lot of information and a lot of factors that we take into consideration to make sure that these systems are secure. Some of those examples would be such as what type of roofing product are you utilizing? So as Kayla mentioned at the beginning, if you're looking for samples, what type of roofing product you work with or are working with is going to be the most important question, because that's going to be able to guide you into what type of materials and what type of product you might be interested in. And then also, how strong are the fasteners that you're utilizing? How thick is the sheathing and what type of sheathing is it? What is the force on that snow retention device? What is the weight of the entire snow mass from eave to ridge? What is the roof slope or the pitch of the roof? And how strong is that individual snow retention device? So without any of testing or any background information, this data would not be complete. I met with a architect in Durango once in Colorado, and she let me know that they allow their local roofers to be able to engineer the snow retention system. Now, I can't speak for that roofer, whether they reach out to a manufacturer to get that information or not. But if they are not reaching out to a manufacturer, there's just some information that's going to be missing for them. They'll be able to search the ground snow load, the slope of the roof, the roofing material type, the sheathing type and thickness, and the rafter and truss spacing. But there's some information that's not able to be Googled and it's not available to them. There's no codes or standards for these types of systems. So those questions would be, what is the strength of this one single snow retention device? How much weight can this thing hold back? What is the pull-out strength of the fasteners? Am I using roofing nails? Am I using screws? How much weight can those hold? And then what is the fail point of the system? So if this system falls apart, what happens? Do the nails get pulled out? Does the snow retention device bend? Does the sheathing get pulled out? Like there's so many ways that the system can fail. How does it fail? And how can we make sure that if it fails safely? So those information, all of that information needs to be handled by a snow retention company. That needs to be tested. And there's a lot of data that needs to be around to be able to engineer those snow retention systems. So these graphs here are just going to show the numbers of snow brackets needed for two projects that are exactly the same except for one factor. All factors of these projects are exactly identical except for the sheathing that the fasteners will go into. So we're talking about the number of brackets to install per roofing square. The one on the left is 7/16 wafer board. The one on the right is 3/4 inch CDX plywood. Obviously, you're going into a stronger material with the CDX plywood, so you are needing less brackets. We can only be as strong as the material that we are attaching to. So if you're utilizing a plan that you received previously on another project that is so close to this one, maybe they're across the street, they look identical, still send in that snow retention checklist, still get yourself a plan. This way you can make sure that you are not overcharging that client like you may have done if you had installed 23 snow brackets when you only needed 11, or make sure that you will not have any type of failures like you could if you only installed 11 and then we decided maybe we needed to hit a budget. So we cut back the plywood and go with a wafer board on that project. And so then you're only installing half of the amount of snow brackets that you needed. So all of these different types of situations will change the way that your snow system functions. In heavy snow areas, you'll be having those brackets installed from eave to ridge. The dimensions will change for this for each and every project. So don't just assume, okay, well, we're 12 inches off the eave and we're going to scatter them just from that point. That's not how these function. We want to make sure that we have all of the details for your project. It's something that we do all the time, and we still are always surprised sometimes when those layouts come back just on how much they can change from one project to the next. So these are just some examples of what a snow bracket layout can look like, what a snow fence layout can look like. But if all of these systems or all of these parts of the system are not taken into consideration, these systems can fail. We're talking about holding back thousands of pounds of snow And relying on the roofing material or relying on the fastener, relying on the seam. So it's very crucial that all of this information is accurate when it's provided to the manufacturer, and that we're not just guessing on allowing some random product to hold back thousands of pounds of snow, such as plastic brackets. So plastic brackets are the one type of snow bracket that I cannot just support. So we're adhering to the roofing material. There's just so many reasons that can create an issue, whether it doesn't seal or cure properly, if the surface is not dry or dirty. Oftentimes, I just say that these make really, really good lawn ornaments because that's where you find them. You'll see the little Band-Aid marks all across the roof where they're missing, and usually they are laying in the flower beds after that first season. So this is the only thing that I can recommend against, beyond just placing snow brackets wherever you'd like. We recommend against partial installation and then plastic snow brackets for sure. So when you're dealing with other types of issues, so here we're seeing snow brackets that are not going up the entire run of the roof. They've been pulled out and pushed over. Sorry about that. And right here, these should be installed with a lag bolt or a large Simpson screw going into structure. They are not even quite at that head wall, so they're not going into any type of structure there. And this far right photo, all of that upper roof should be covered because otherwise you're now allowing for the momentum of that snow sliding into that lower roof. So these were 3 systems that were not engineered and did fail. And this is something that I could supply you with a whole day's worth of all different types of products on the roof as a partial system or as an unengineered system and the way that they have failed. So it's very important to have that system engineered and allow for that liability to go back on the manufacturer. So no matter how strong your product is, these are 1/4-inch plate steel snow brackets on the eave of the roof, and that snow just came sliding into them and pulled out the sheathing. So making sure that the brackets are being utilized as a system, not just as a row along the eave, is very important. PVC pipe should not be on the roof as a snow retention device. I've mentioned this previously. And then making sure they're utilizing the correct type of bolt or screw to install these. The snow fence is being installed with like 1.5-inch screws that would hold up a mirror in your bathroom. So I've definitely touched over partial installation. This is one reason why codes and standards don't exist for snow retention, is because they could say 6 brackets above a doorway, but you're talking about a glaciated mass of snow. That also comes into play when we're dealing with snow fences. So with the fences, they're going to act a little differently because you can only still be as strong as what you are installed into. But with that, the whole weight of this entire run of the roof that does not have snow retention on it is now relying on that seam that does have snow retention. So that final seam can definitely be pulled out or damaged tremendously by allowing it to try to work overtime on all of the seams that do not have snow retention. So same concept here. This homeowner had snow retention along the front. It worked flawlessly. So they decided to come and install just above this gutter line, which would be okay had they ran the rest of the snow retention across that run of the roof. But since they decided to not, that last 4 seams over that gutter was holding that entire mass of snow across the whole rest of the roof. When that happens, you most definitely can see damage. Any type of weight from the upper roof to the lower roof, not considering that in your design of snow retention system, can cause damage such as this. This is only about a 1.5-foot gap from that upper roof to the lower roof, and you're talking about a whole portion of your roof system that has full water intrusion and a whole lot of damage at that point as well. So I have some information about eliminating ice dams. If anyone wants these slides, I can forward this on to you. It focused very largely around the roof, like the roofing type, and allowing for a cold roof system So with this, I mean, you're increasing your R value no less than R50 of a closed cell foam, and you're basically blocking off that attic completely and allowing the attic to be the same temperature as the outside ambient temperature. So these are very complicated roof systems, and the reason I'm skipping over it is because there's a lot of WUI codes going into play currently that are really pushing back against ventilated roof systems. And I know that there's a lot of products that are missing to allow those roof systems to happen properly while still being approved by that code. So I'm going to just skip over my cold roof system information. The owner of our company wrote a manual about cold roof systems years and years ago. So it's something that we have a large amount of information about, but it's not quite perfectly directed to my presentation or anything that way. So if anyone wants those slides, I'll be happy to share them. But basically, the goal of this presentation is to discuss more the snow retention. And we can show, I mean, this photo here definitely shows you the differences between a non-vented traditional roof and a cold roof vented system with snow retention on it. These are in Sun Peaks, Canada. The roofs are only about 100 yards apart. So it does work very, very well. We're just missing a whole chunk of products on the market currently that can help both of those things be supported accurately. So that does conclude the end of my AIA portion of my presentation. I am more than happy to take any questions at this time, or I can go ahead into a little tiny bit about TRA, whatever would like to be done first.
Awesome. Alrighty. So we can go ahead and jump into questions, if that sounds good.
That's perfect with me.
All right, here we go. Yeah. Sorry, I had to pull it up. All right, folks. Yeah, if you have any questions, now is the time. So feel free to go ahead and drop some more in there if you'd like, but I'll go ahead and get started with what we have. Um, First, I have somebody asking if you'd be willing to share the PowerPoint presentation. Is
Yes.
that something you can share? Okay.
Absolutely. Yes. I just need an email for that. So if anyone has those specific requests, just let me know. It does usually have to come through like a Dropbox or something similar just because it is so large.
Okay, perfect. Yeah, we'll share the email address of this person asking. And folks, if you registered for this event, we always send a recording of the webinar right after as well, so you can use that too. All right, so next up we have how can you penetrate roofing systems with lag screws or other screws not create a leak?
Absolutely. So most of our products are made to go underneath the roofing material, which is why it's very important to have these included as the new construction time frame and not have to go back as a retrofit. So most of our products are going to interlay with the roofing material and be covered fully by that roofing material. So like deck mounts, all of those types of things will be going underneath that roofing material that's being installed and be interlaid with those. Any type of product that we do have for retrofit, we would like to avoid retrofit situations, but unfortunately, it's something that comes up usually 2 seasons after the install. They realize they're having a lot of problems with the snow sliding, and at that point, it's either penetrate the roof or continue to have those major issues that they're seeing. So it depends on the situation and the homeowner if those retrofit situations work better or if they're willing to keep that risk or that issue that they're having. So it just completely depends on the concern, but that's why a new construction and having that in the design is much more important than following up with it after the fact.
Right. Gotcha. Thank you.
Of course.
All right, next question. Metal roofing systems are usually designed to be fixed at the ridge and side on clips, expanding and contracting at the eave. Do the snow fences clamp to the seam yet still allow metal expansion and contraction?
Yes. So we clamp to the seam with clamp-on systems for standing seam panels. With that, anything over 50 feet will allow, we have a gap that we allow for expansion and contraction. That's always in our designs. Anything less than 50 feet, we've never seen an issue with the expansion and contraction, but there is additional bar or additional pipe on the end of every clamp. At the ends, there's usually 6 inches, but we ask that it does not exceed that 6 inches. So it allows for that expansion and contraction to happen even on those shorter runs of pipe.
Okay, got it. Awesome. And next we have, what considerations should be taken into account for reactions between using different materials for roofing and the snow retention systems?
Absolutely. So, I mean, I can't speak to other types of materials, but we have always tried to make sure that we are using the most similar metals possible. We use a zinc plated stainless steel, and then we also powder coat as well. I know that there are some aluminum and other types of products out on the market. We have really just strayed away from those just to make sure that we're always manufacturing the most similar metals that are going to be available in panels.
Mhm. Awesome. All right. Next we have, please recommend what is the best planning, sorry, please recommend what is a planning level best practice for fence spacing in the SLC area on a steep slope metal roof.
So that spacing would be dependent on that project specifically. If you have a project in mind, just send it to us. Like sales at TRA Snow and Sun is the best way to send those layouts. And some information on the project that we would need is going to be like your panel spacing of that specific project. So if it's 16 inches on center, we need to know that. We need to know what type of seam profile it is. So if it's a double lock, single lock, snap lock panel, what the height of that seam will be, because that's going to change the type of clamp that you're utilizing. And then also like the slope of the roof, the ground snow load, all of those things will come into play to be able to provide you with that spacing and that amount of product needed. So it's definitely not a one size fits all type of system. It needs to be specific to your project, even if it's in our same region in Salt Lake City.
Okay, gotcha. Okay, and then I think this is similar to the earlier question, but I will ask again just to reiterate. But what roofing materials are best for a retention system?
So so personally, with me having a metal roof myself, there's not a single metal roof that goes up that I wouldn't recommend snow retention on in a region that receives snow. I'm also doing a lot of work back east with contractors that are installing Tesla roofs. So anytime you're having like glass panels on the roof, those types of things, snow retention needs to be considered. And then as you get into like the mountain regions, it doesn't matter if you're dealing with shakes, asphalt shingles, a synthetic slate, any type of roofing material that way. When you're dealing with large snow loads, if you have a sloped roof, you need to be considering what type of snow retention would be beneficial and just weighing those risk versus rewards. If we don't install it and there's a problem, what could that problem be? Is it just going to be a deck railing? Is it going to continuously fall on these people's hot tub? Is it going to fall directly in front of their garage and they won't be able to get in and out? Just considering that risk versus reward, because there are some houses or buildings where snow retention just does not make sense, and that's okay. But it has to be a conversation with that client. And I always recommend, as an architect or as a contractor, of just covering yourself, like making sure that you ask those questions and that you keep record of it, of that customer declining that information, so that you always have it. And if something does come back and happen, that you just are not liable in those situations if you've asked that question and been turned down.
Awesome, thank you.
Of
Um,
course.
and I
I'll
think we
just,
have time for one more, maybe.
if
Go
you'd
ahead.
like, Kayla, I can just run through these slides real fast.
Okay,
It might answer some of the questions because we do the
that's a good
free
idea.
engineered layout. So this is no cost to the architect. They're able to receive those from us directly. There's obviously guide specifications, data sheets available. This is all available on Acelab as well. With the system warranty, we're a small company. If you have an issue with our systems, you call and speak to the CFO. And we're also working with an ASTM task group to try to develop standards for the industry. So if there's any questions, concerns, you need a layout, all of those things, we're here to help you. And if there's a system that we've never seen before or a roofing issue that you're having, that's exactly why we're here. We test this stuff. We want to know what's going on with it and the issues that are seen with designs and all of that. So communicate with us and we're here to communicate back, basically.
Yeah, I think that was helpful. There was a couple more questions, but for the sake of time, I think we can go ahead and wrap it up here. And then, you're more than welcome to connect with these folks afterwards, Mindy, with any
Absolutely.
remaining questions. So we'll make sure to share contact information with you. And as I mentioned, folks, if you filled out that poll, keep an eye on your inbox. You'll get an email within the next few days connecting you with Mindy and her team. So that's another great opportunity to ask any project specific questions, set up a one-on-one meeting if you'd like. Yeah, so keep an eye out for that. It'll come from a no reply Acelab email address, as I mentioned earlier. But yeah, I think that covers everything. Mindy, any final notes you'd like to make?
No, thank you everyone for attending, and I apologize again for my dogs barking.
It actually really wasn't too bad on my end, at least.
Okay.
But yes, thank you so much, Mindy, for the really great presentation. And thank you so much, everyone, for joining us today. We hope you have a great day.